Hi everybody, welcome to TGIK 187. Uh, I'm Pushkar Joglekar. I work at VMware and I'll be your host today. We are going to talk about very with a very dear friend and also a topic that is very close to my heart, which is uh, gaining more trust into release images for Kubernetes and the work that has been going on for a few months now is what we'll discuss, which is basically an image signing cap that we have been working on. So if you've joined us just now, feel free to say hi in the chat. Let us know what you want us to talk about and what you would like to hear. And while we're doing that, I'll welcome my friend from SIG release, Adolfo Garcia Veytia. And with that intro, I also want you to tell us how we should actually pronounce your name because I probably messed it up and I should have asked before.
Don't worry, I'm not sensitive to that. So my name is, well, if I speak it like native Spanish speaker, it's Adolfo Garcia Veytia.
Okay.
But I usually go by Puerco everywhere, so feel free to call me whatever. I don't
All
know.
right. Perfect. So I was 70% there, looks like so. Not
Yeah,
bad.
it's perfect.
All right, cool. So Adolfo, maybe tell us a bit more about your journey in Kubernetes, what you do day to day, and how you ended up working on this cap.
Sure. So I've been working with securities between 2 and 3 years now. I originally started with as a shadow in the release team some years back now, um, and I actually started with Ray Lejano and James Laverack, who were recent um, leads, Kubernetes release leads, and from there I started gaining some interest in some of the release processes and tooling that power all the Kubernetes releases, and started working on. I led the release notes team for Kubernetes 119, and then from there, some of the changes that I started working with under the guidance of Sasha Grunert, who uh, has been one of my dear mentors in all of this journey. We started working on automating the release process more and more, and then when we were at a comfortable place where things were already rewritten in Go, and uh, the level of automation had been fully migrated from the old Bash scripts to Go, we started thinking about improving things. And then we some of the work that we started doing involved securing things a little bit more. The first effort was about a year and a half ago, and where we at some meeting someday, Stephen Augusto suggested that we should um, produce a bill of materials for Kubernetes, and then we started working on that. And then when Project Six Store, which we're going to be talking about today a lot, started, we started meeting with them. I think it had been up for a couple of weeks, really. And then we started meeting with some of the founders there, and then we decided that it was a way we wanted to start securing the images, signing them. And it's been a long way, but we're almost there at the point that we can start uh, I don't know, releasing signed images. So we're going to demo some of the efforts that have been going on into that cap. Uh, and yeah, and I'm also really happy to be here with you, Pushkar, one of my favorite people in the Kubernetes uh, land.
Thank you for the great context in the intro and saying nice things about me. Uh, One thing we do generally as part of TGIK is go to the usual notes which are linked in the YouTube live, tgik.io/notes. So you can all go there and we can all collaborate to add new things that may be missing there that you see in around cloud native community or Kubernetes community, and we can have a quick discussion about it. Now with the Mac updates on my side, I've lost screen share access. So I'm gonna ask Adolfo to share the screen for me, and then we'll go and walk through the notes together.
Sure thing. Let me share it. Um,
All right.
should be up.
So
Yeah.
okay, cool. Maybe we can increase the font, Adolfo, a bit more. Okay, perfect.
Okay.
I think yeah, this is good enough. So, for folks who are wondering about the thumbnail, by the way, both Adolfo and I love biking. I am a relatively novice biker. Adolfo has done a lot of. I let him explain cross country biking, and he has an actual bike behind him as well. So that's where this came from. If you like bikes and want to talk about it, I'm happy to hear from you in the chat as well. So, okay, so enough about us. Let's go back to week in review. So, scroll down a bit more. Yeah, okay. So, this week, something that I think personally is very important for us in the community uh, happened. So, there was an open letter shared by some community members to Linux Foundation where people explained their concerns about some of the conferences being in Texas, and in matter of I think 1 or 2 days, Linux Foundation submitted a statement explaining their perspective on this. So please take a look. This is something I deeply care about, and I hope it is important for you, and hopefully you are able to be learn it and understand it a bit more. So next one, back to Kubernetes land. There were patch releases which happened this week. I think one of our friends in SIG release did the patch releases this week, and the main reason for the patch release, if I remember right, is Golang was bumped for all of our components for Kubernetes. So those patches are available. If you want to go and grab them, please go ahead and upgrade. Next one after that are a bunch of CVEs, but the first one is CDF launched a SIG software supply chain, which and there is a blog about it that you can go and read about, explaining why this is important. And as Adolfo mentioned, Kubernetes community also has started work on supply chain almost since last year, creating an SBOM for Kubernetes. And so, with the whole community as a whole, from Cloud Native and Cloud Delivery Foundation, being so focused on software supply chain, it's just great in my opinion. Next one is again a bunch of CVEs. There were a few CVEs a couple of weeks back, and then this week also we had a cryo vulnerability available or published, and then with a fix, a pretty important one, I would say, if you're using cryo. And then there was an OpenSSL CVE as well, which was published again. If you're using OpenSSL, something to take care of. One thing that did happen, which is a good thing in terms of how end users, as like government agencies for Kubernetes, continue to push us into becoming more and more secure. So NSA and CISA, for non-US folks, are US government agencies who published Kubernetes hardening guidance, which they had published the first version in August last year, and then now they've published this year, this week, an updated one. And the main update between the first release and this one is they've tried to get community feedback, and industry experts have tried to weigh in on what was missing, what could have been improved in version 1, and then they have really honestly done a good job of trying to address that. One thing that's also a pleasant surprise for all of us in the community is one of our blogs, authored by Jim Angel from Google, Savita Raghunathan from Red Hat, and myself, was actually cited as one of the references in the updated guidance, which in my opinion like is a great example of a positive feedback loop of end users and community trying to improve and push each other towards a better product and a better project. So that's about the news from my side. If you have anything you want to add, please go ahead and add it. We'll see who has joined on the chat now. So hey Eric, nice to see you here. um, Yunusa Namadi is excited about image signing. Let me know if I did not good job or bad job pronouncing your name again. And John, good day from Minnesota, and Alex from sunny Northern California. Yeah, it's actually quite a good day today. I agree, Alex. So
Nice to
hope
see some familiar names in there.
yeah, definitely. So hopefully this is useful in terms of the news in review. Now we'll stop sharing screen for a bit and talk about why we're doing this cap and what's really going on. So, Adolfo, I came to know about this cap maybe 6 months ago or so, maybe around in October, November, if I remember right. And the idea was, hey, we have an SBOM and we have a very good tool like cosign with a very good user experience to sign images now. And so there is a chance that we can actually sign our images that are shipped in every Kubernetes release. And then there was some discussion, and for folks who are unfamiliar with how design discussions happen in Kubernetes, a KEP was created. KEP is basically a Kubernetes enhancement proposal, which has a template and a design discussion. It is basically a design doc to explain why this is important, why we want to do it, how we are going to do it, what different SIGs are going to work on it. And then everyone gets a chance to weigh in, share their concerns, share their feedback. And the idea is through the combined knowledge of the community, the total uh, uh, output or the outcome of the cap improves and the design is stronger because of it. So that's what happened in this cap. I believe Sasha and Porco have been leading that from SIG release side, and me from SIG security. Always happy to see somebody apart from SIG security doing great work in security. So I was like, hey, I am here too. I would love to help, and so that's how I joined and been working on implementing it. Um, what's been what has been your journey on this cap, Purko, and what are you really looking forward to in terms of the final outcome in the coming weeks?
Yeah. So yeah, like I was saying on the introduction, we started thinking about securing the releases a little bit more. It's been for about, I think it was like 2 years ago, and the after we started publishing the Kubernetes SBOM, uh, we saw that two things happened. So the first one is that the project really, whenever Kubernetes does something, it really has the ability to impact a lot of practices in the cloud native space. So when we produce the SBOM and the SBOM tool, we've seen some adoption of that tool to start producing SBOMs in related projects. So if you check out the Istio releases, they have their SBOM, which is built with the same tool. And then the key with when we started thinking about signing the images, and we started talking with Sigstore, yes, cosign is a tool that enables easy signing of images, but the key aspect in the key feature of Sigstore is that the way that you provide the identity to the signatures to the so the key way is that the way that you authorize your identity to be used in the signatures is a really easy flow that can be implemented inside of automated processes. So when you have an interactive flow uh, in cosign, you will go and authorize the signature to use your identity by authorizing an OpenID flow, right? But this identity can also be used by automated processes that can emit OIDC tokens. So we are using that feature of the flow to authorize and give the signed artifacts the identity that we want from the Kubernetes organization. We're going to see that in some detail. So we started working on the well, the signing effort that we're explaining today is part of a larger effort, which is to make the Kubernetes releases SALSA compliant. So SALSA is a framework that has some guidelines and suggestions for software releases that will make them more secure. Uh, if you follow some of the SALSA recommendations, you can ensure that at least the most common attack vectors of software supply chains are a little bit better protected and guarded against. So the idea is to take the Salsa framework and try to apply it as much as we can to the Kubernetes releases. Um, we started implementing some of the metadata necessary, and during KubeCon in Los Angeles back in October, we announced that we had reached the first level of Salsa, which is basically providing the metadata necessary to inspect the release process. And as we go up in levels, the next ones start requiring that all of the metadata, the artifacts cannot be falsified, and that means we need to add digital signatures to all of them. And this is where we are today. So there are three, I'd say, signing efforts that should go into the process. One is signing the images, one is signing the binaries that we release, and finally signing all of the metadata files that we produce, like the SBOMs and the provenance attestations. And like you said, PJ, during the last months, the first thing that we've been working on is signing the images, which are going to be the first ones to go out signed. And we've been seeing it's been like a really nice collaboration between not only SIGs, but lots of people helping into the project. The signing pull request that is going to modify our tooling to finally sign the images has been open, I think, for a month now, and it's been always getting the necessary patches from folks all over the place that have been adding the needed functionality to our libraries, to the tooling that releases Kubernetes. Like you, Priya, yeah, you submitted one of the parts, which I'm very grateful for you having taken that, and yeah, so this will, once we land this the signing MVP, which is the minimal vial demo that we're doing for signing, images will be signed. But the most important part is that the signing infrastructure, which involves our libraries, our tooling, is going to be ready to rapidly implement the other two signing parts, the binaries and the metadata. Another thing that we should also mention is that this effort goes hand in hand with SIG security, but also as well with SIG Kate Infra. So Kate Infra are the folks that volunteer the time to ensure that the infrastructure that powers Kubernetes, so whenever you submit a pull request, it runs on infrastructure that is handled by SIG Kate Infra, and all of the Google Cloud infrastructure that handles that our processes is handled by them. So without them, we wouldn't have been able to establish the needed service accounts, the needed projects, and all the requirements for this. So big shout out to them as well. I think you're muted.
Good call. Yeah, I completely agree, Adolfo. Say Kate's Infra are really the people in the background who make keep things working. The pull requests are so visible, new features are visible, but nothing will work and nothing will matter if those are the people who if they stop working and continue to help us and continue to make sure the infra for Kubernetes is up and running always, so that our pull requests get merged on time, our jobs and test creates are running and green, and we get alerted if things go wrong. So definitely agree.
And
uh,
another important part is that if you think about it, when we sign images, we are operating right in the middle of the border where SIG release and SIG gates infra meet, because
right.
we produce the releases and the infrastructure and the registries, and that is part of what they handle. So it's
Hmm.
right in the middle.
Yeah, exactly. That makes a lot of sense. So you shared a lot of information, so I'll try to summarize for folks who joined a bit late. Basically, the image signing MVP is really a small part of a big project. Then the idea is eventually we want to make our Kubernetes release process as secure as possible. And for that, one of the things we are looking forward to is how can we improve our compliance with the Salsa framework. So we started last year with Salsa level 1, and the idea is now to go and continue up to level 3. The MVP this time is going to be signing images only that are part of Kubernetes release, and the tool behind that is cosign. And for folks who are in case unfamiliar, cosign is, if I remember or understand correctly, an acronym for container signing. So that's basically a tool that depends on Sigstore, which is a generalized tool for signing artifacts, and it allows, like Purko was mentioning, an ability to authenticate the signer, so that we not only get integrity but we get the authenticity when a signature is created for any artifact. So all of that work is going on right now. With everything in software, we're doing incremental updates, so we'll try and see if we can push the images, if maybe it's right to say for version 124 that are signed, and then for all successive releases there is a chance that we'll continue to sign them and maybe add more artifacts that are also signed in future.
Exactly. See, yeah, the idea is to secure all of them so that you can trust and verify the release process from start to end, and also make sure that, so when we do a Kubernetes release, we have a staging process and then a release process, and then until last year, you could not attest. The release process could not attest as to the artifacts that it's consuming from staging. That is
Yeah,
now that they are now linked. So with metadata that can, so that when we release, we can make sure that those artifacts are coming from where we expect them to
yeah,
have originated from.
yeah, makes sense, makes sense. So we have got few more chat messages. uh, Arnaud is saying hi from France, and we have Moz from Dubai. We have Sevi from sunny Amsterdam, weird but true, and happy TGIK everyone. And somebody with a name called Native to the Cloud is showing their love for you, Purko. And maybe this is a good time to tell the story behind your handle. I know the story, but if you're comfortable, maybe you can share it with everyone.
Yeah, well, I it's nothing too elaborate. So when I was in high school, my now wife and me started calling each other puercos, and then I don't know, for some reason it turned to be a handle that was free in most services, so I just took it and down puerco.
Nice. Okay. And if I understand correctly, the word actually means pig, correct?
Exactly, big in Spanish.
Okay. Cool. All right. We have another person joining, Gabo from Mexico. Hey,
Oh,
Gabo.
Gabo is my big friend from for since I was a kid.
Oh, perfect. So he was actually a witness to the whole story you just told us.
Right.
All right. Great. So I think I'm all set to dive deeper and excited at the same time. I do have some knowledge about what we are doing, but I also have a lot of questions. So what I was hoping is I'll act like somebody who is novice and completely unaware of what's going on, and we'll let you kind of take the stage and share what you know, and then we can dive deeper into whatever you share, and hopefully we can get to see some demos that work or maybe not don't work. So with that, I'll give
I-
you back sharing access, and then we'll see your screen.
Awesome. So the first thing is I prepared a little presentation just to make sure that we um, because I feel that sometimes the processes running inside of the release process are kind of abstract. So I wanted to give a brief overview of what how it works and how we are trying to make things work once we finish the signing effort. So
Yeah.
let me. I
Okay.
think
I think, yeah,
my
I
screen
can
is there, right?
see. Yeah, I
Okay.
we can see your screen now.
Okay. Perfect. So let me just take this out of the way. Okay. So this is the introduction. So uh, I wanted to start with introducing you with some of the tooling that we use. So the Kubernetes releases are powered by a tool that's called CREL, which means the Kubernetes Release Toolbox. CREL does many things. It creates release notes. It powers the staging and release, and it has like I don't know 10 different functions. It also handles the image promotion pull requests, which we're going to be talking about today. So many things. Uh, and the key thing here is that the main function that we're going to be inspecting is when it does the staging of the Kubernetes artifacts. So as part of our Kubernetes release, we release many things. We build a bunch of tarbles, the documentation. Well, not the documentation, but the release notes. We do the container images, the SBOM, but we're going to be focusing today on the image release process. So when we run a stage, Krell builds the container images for all the architectures and platforms that we support, and then after every staging run, it uploads the images to a staging registry, and then after that, once they're staged, the release manager's team inspects those images and the rest of the artifacts, and if we decide that the release is looking well, we move to the release process, to the actual releasing of the artifacts. To release the container images, we run another tool that is called the image promoter, or the command utilities called kpromo, which also handles other kinds of functions, but we're going to be focusing just on the image part of it. And kpromo, what it does is that it takes the images from the staging repository and then copies those images to the different mirrors where we release the container images. So that's the way it works today. The way this works is that we open a pull request. There's a manifest of the files that should live in the registries, in the release registries. So the way it works is that you open a pull request modifying that manifest, and you tell the image promoter to release new images. And what it will do is go compare the source registry, find all the images that are missing from the target registries, and copy them, and then they get released. Uh, this is an automated process that happens as a post-submit job in Prow once we merge the manifest.
So we are doing this using the favorite concept in Kubernetes, reconciliation.
Exactly. Yeah, you could say so.
Mhm.
So this is the way it works today. And now I want to speak a little bit how we are modifying this process to ensure things are signed. So the first thing that we did was modify. Well, the first thing was actually enabling and pulling all of the Sigstore libraries to merge them into the Kubernetes release tooling, so that we have the signing capabilities built in. And then the next thing was modifying Krell. So Krell, now the way it works is that when it runs and it stages the images, it will sign them. And so Krell runs and pushes the images to staging, and it will stamp them with a I'm listing there as a project signature. And I'm calling it the project signature as in release engineering. Do not think about Kubernetes as a whole, but at this stage we're talking about a signature that what that signature expresses is that the images that you can find in the staging repositories come from the release engineering team. So that's the first one. So then when
One
yeah,
one question here, Purko. So when they are signed, like you mentioned earlier, there has to be an identity that is tied to it. So what is that identity that will sign that image?
it's a service account that I should have listed here. Since we just created it, I don't remember the exact address of the service account, but it's a Google Cloud service account. It's not a service account that runs the release process. It's a service account that we created solely for providing the identity of the signatures that release engineering provides. It's called, I don't know, all of the Google Cloud service accounts are similar, but I can look it up later if you want.
Right. And then the idea is the credentials of that service account are only known to very few members in the release engineering team, correct?
Exactly. In fact, the credentials, there are no credentials. The way it works is that since this is all built with ODIC, OpenID Connect flows, uh, the way it works is that Krell will impersonate the service account. Uh, it will generate tokens, which will pass to the Sigstore tooling, which will then go back, contact Google Cloud, ensure the identity is correct, authorize the signature, and then we can send the images using those tokens.
I see. So we're using workload identity in this case to
Exactly.
verify that the service account that's trying to sign is actually a valid service account and has permissions to sign this particular artifact.
Right. At no point beyond the short-lived tokens is any credential floating around or hard-coded anywhere. This is all run using solely workload identity. So once we have the image in staging signed, the image promoter will come, and then when it promotes the images, it will also carry that signature to the uh, to the final registries. So at this point, in theory, we could ensure that we have signed images, right? But if you think about it, the way the signature is coming from the release engineering team, and we wanted to provide a way for the whole community to sign their projects. And to do that, we couldn't simply just carry the signatures forward, because we wanted to provide like a stamp of guarantee of a signature at the whole Kubernetes wide organization. So what we did was modify the process in the following way. So once we have the images promoted, the promoter will assume the identity of another service account, which will provide the identity for the whole Kubernetes organization. and push those images and sign one of the images. So it will actually go and sign the image that has already been promoted, and it's out there in one of the mirrors. And once it's signed, it will go. The promoter will go and take that signature and copy it to the rest of the registries. The reason it's doing this is because if you sign the registries many times, if the promoter were to go and sign Asia, the US, and EU separately, you would end up with different signatures. So we are working to do the copying of the first signature so that we ensure that all of the images get the same signature. And in the end, you get an image that is signed twice. One time by the project, which in this case, this is a special case because it's Kubernetes itself. But if you think about it, some of the smaller projects, say, for example, that you were to release Ingress Nginx, they could provide their own signature and then release it. So you end up with each of the images in their mirrors signed by the project, and then a second signature of the Kubernetes wide organization. So at that
Right.
point, you can basically celebrate.
Yes. And this is so interesting because sometimes the general assumption is I just have to sign once and then I'm done. So in this case, now that we're signing twice, I wonder as an end user when I'm verifying my signatures or I'm verifying the signature of the image I'm pulling, which signature I am actually going to verify and how would I know?
Uh, you are going to be verifying both, which brings me to the next topic in this. So
Perfect.
if you think about it, um, let's go to the next one. Um, Let me go to the next one. So this is the current trust model. You have a Kubernetes signature that ensures that the artifact that you are looking at actually passed through the official promotion processes of the Kubernetes organization. And by the way, this in the end is we are trying to make this work as well for the binary. So if you download at some point, I don't know, kubectl or kops or one of the other binaries of the other projects, we're trying to make this work for those as well. And you get two signatures. And the first one establishes that yes, this artifact in fact passed through the Kubernetes promotion processes. And you get a second signature that what it tells you is that someone somewhere signed it. But if you think about it, you have like a disconnect problem in there because while you have two signatures, you simply don't know who the first signature is, right? You can verify that the first signature was in fact from Kubernetes, but you cannot authorize the second. So we are working currently in improving this trust model, also working with some of the extremely smart people that are Sigstore contributors. So enter Tough. Um, if you're familiar with Tough, for those of you who are not, I'm not a Tough expert, and explaining Tough could take a whole or a series of shows all by itself.
Explaining toughest stuff.
Exactly. Yeah, that could be the motto. But we are working to ensure that we have a proper delegation of trust, and I can briefly explain how it's going to work. The way it's going to work is as follows. So the first thing is we have a Kubernetes. Well, this is the idea of how it's going to work. It's some of the code tooling and the final specification is not there yet, but we're actively working on it. The way it's going to work is as follows. So we're going to have a Kubernetes delegation that gets its identity, its trust root from the full CO root that is the source that derives from the root key from Sigstore. So Sigstore has a topmost root certificate that is itself generated from was generated in a signing ceremony last year, and the next one is going to be uh, shortly. I'm not sure of the date, but it's about to get a rotation, because the way the rules are generated is that you have several signers that take part into the key ceremony, and they sign using TOF. They all sign the the necessary metadata to generate the full zero roots. So the idea is that no one person can generate new roots for the Sixer project. You have to have at least, I think, if I remember correctly, there are five key holders, and from those, I think you have to have at least three to generate a new root. And once you have it, you get the new Sixer root. Then Kubernetes as an organization, and by the way, this is also in the works for other types of open source organization, not just Kubernetes. For example, there is a current effort, a really interesting one, to build this same sort of delegation into the Ruby Gems community, for example. So the idea it's going to work is we have a delegation from Fulcio, and then Kubernetes is going to be able to delegate identity and trust to its, let's say, smaller projects, or baby projects. I don't know how to call them. I don't know if it's offensive to call them baby projects, but the smaller projects, not the whole Kubernetes project, but the others. And then
Sub projects maybe is the right way.
okay, sub projects. And then, so let's take, for example, Cluster API. So Kubernetes is going to be able to delegate to Cluster API a means for them to generate their own keys that can be traced back from Cluster API to Kubernetes to the full zero root, so you can verify the whole chain. And then Cluster API can determine how their signing at the project level works. They can delegate trust to one person, or they can delegate trust to more than one person's, and those can be reached back to the full zero root. So that's what I wanted to explain. If you think about it, we are trying to plug some of the identity gaps wherever we can, and I think the efforts are going really well. Some of the tooling, as I said before, doesn't exist yet, but we are trying to move this as fast as we can, and to provide the necessary guarantees for the signed artifacts. As
Right. So if I understand correctly, the missing part right now is Kubernetes signing key has a chain of trust with Fulcio, uh, but the signing that is done by release engineering team, that is missing the chain of trust right now.
exactly. So right now, the scenario we are looking at is not this beautiful flow and delegation of trust, but this one, where
Right.
we get one sign two times, and you simply have to trust that the first signature, if it's present, because while we are going to be signing all of the artifacts that go through the promotion processes, the projects themselves are not required to provide the first signature. So
Right.
if you are part of a project and do not have any signatures in place right now, you can keep doing it as it is right now. Or if you have a signature, it's going to be verified and propagated once we promote your images.
Right. And also one thing maybe worth confirming is when KRail will build the image, it will sign it and push to staging. And then when KPromo is promoting the from staging to production registry, before promoting, it will also verify the staging image, correct? And
Right.
say like, oh yes, I know this image is actually signed by release engineering. So because it's signed by release engineering, I'm going to feel comfortable that okay, this is good to promote.
Exactly. Well, there are two parts. So one is like in all things identity, there's uh, identity, but so and authorization. And so right now, the way it's going to work is if you sign an image right now, when we take it as a candidate for promotion, we're going to verify that signature.
Right.
But we do not have any means of making sure that the identity is someone allowed to sign it. So we're just going to verify and use the signature for integrity of the image and let it through if it matches.
Yeah.
Once we have the Kubernetes delegation in place, we are going to be able to ensure that whoever is signing that image is in fact authorized to release for that project,
Correct. Yeah. That
which
makes
is
sense.
yeah, and it's going to be like yeah the ultimate ensuring of what things get released.
Yeah. This is similar to like the uh, PKI model, where if I am a self-signed CA, I am able to establish TLS a handshake, but I don't know whether that CA is someone I can trust and whether that CA is allowed to work the way it needs to work, and the right people are actually have access to that private key.
Exactly.
But in this case, when there is an well established CA, then I know like you are not going to get that CA private key unless you prove that you are actually the person or the organization that the CA belongs to.
Exactly, because you're missing the third party who
Right.
attests of the identity. I mean, at this stage, it could be possible to do that if, for example, so let's say that you release an image
Hmm.
and you sign it. Here's my image, sign Pushkar,
Right.
and then I get it. And if we establish that in by other means that you Pushkar can release, and I have your service account, I can
Yeah.
trust the Fulcio tell me, okay, so this is really comes from Pushkar, okay, and I know that. But using a tough delegation, you will be able to cryptographically verify the chain all the way, and
Yeah.
without prior interchange of the identities. So you can
Right.
basically follow all of this. It's quite possible that I'm saying something that is completely wrong, uh, but because I am just a tough user, not a tough expert. But f- from our understanding, this is the way
Correct.
it's going to work.
Yeah, yeah, that makes sense. I see it like the analogy. I try to remember when I have to figure this out is, if I have a photo and a sign of a signature of myself below it, I can say that, hey, this is my photo and I can sign it again for you. But I can't, you can't be sure that I'm actually Pushkar, because I'm just telling you I'm Pushkar and I can sign it the same way. You just think that okay, this might be Pushkar. But if I have a passport with the same photo and my own signature, then the person who sees the passport knows that, oh, that government has actually confirmed that this person is actually Pushkar, and he can verify the signature that it is actually, he can do the same signature again. So now I have a chain of trust with a third party that I trust, and Pushkar also trust, and that third party has verified Pushkar is actually Pushkar.
Exactly.
Yeah.
Yeah, it's like the old traveler's checks where you have two signatures
Right.
from the same person.
Yeah. Yeah. Exactly. Okay. Cool. That makes a lot of sense, and I'm glad like we're thinking through all of these things, and also the fact that we're using short-lived secrets. So, as a result of that, any potential chances of that secret or credential being leaked or misused, at least the chances reduce. We can't be guarantee everything 100% of the time.
Right. So I don't know if we could try to simulate this process locally by using the my branch that contains the promoter, which is capable of signing already.
Yeah.
Um, we could try and do that,
Yeah.
or
Yeah.
maybe
I think
uh,
that sounds like a good idea. One thing I always struggle explaining people, uh, and so maybe we can help demystify, is how does the signature actually look like? Because sometimes you just say like, hey, this I have signed it, but nobody really knows like what does it really look like, and what should I do with that signature. So if we go through that demo and like really dive deeper into the artifacts that are created when we sign it and when we verify, I think that would be a lot of fun.
Right. Yeah. So this is one of the things, one of the ongoing debates that we have on the on Kubernetes.
Hmm.
Uh, so we want to provide a link, a URL that you can click and see some of the verification information, but no one there's no one that has. There are lots of ideas around, but we haven't finalized. So what would that look like?
Right.
What would you expect to see if you clicked on a link, the signature, the metadata,
Right.
some nicely formatted page? So we're thinking on that still. Hopefully, we'll be able to provide something at some point.
Yeah.
Okay. So let me go and switch back to the terminal. Um, okay, so let me show you here what's going on. So for this demo, I'm going to try and
I'll just quickly interrupt for folks who are
yeah,
watching. If you think the font is too small for you, please let us know. We'll adjust it accordingly. For me, Perco, it is fine. Maybe increasing once probably could be better though.
okay.
Yeah.
So I'm going to try to build an image,
Hmm.
push it to my personal registry, and then using the promoter, we're going to try to promote it to my registry from my work account.
Got it. Okay. By the way, people are saying we should increase the font even more, looks like.
Okay,
Yeah. Okay, let's try this and we can continue.
okay, cool. So I have a project here that already. So this. I'm going to reuse a demo project that I built with
Hmm.
Carlos Panato, who's not only my personal hero but also my co-technical lead in SIG release. We built this. It's just a project that builds an image,
Hmm.
standard image, nothing less. So it uses Ko. For those not familiar, Ko allows you to produce an image from your Go code really easily.
Right.
Um, okay, so this is going to, and this is running in a script using Mage, which is a tool that we use in SIG release to release things. So it's
Right.
going to build the image. Yeah, it's going to build the image for all architectures and push it to my registry, my personal registry. So um, one of the nice things about Ko is that when it takes the source code and builds the image, it's going to also create a bill of materials for that and upload it with the image. So the images are built, and now the next step in the build process. This is trying to simulate what happens inside of the of Krell, of the staging process. So I'm not going much into the detail of how to build an image because it's kind of outside of
Yeah.
the scope.
Mm.
And then
So
the next yeah.
sorry, maybe you will cover this later. So few things I see on the screen happened while
Mhm.
we were building the image. It says generating ephemeral keys, retrieving signed certificate, and then a
Right.
browser URL opened. Maybe you're gonna cover it, but I'm
Exactly. This
curious
is
about
the
that.
yeah. This is the part where I was going to what I was going to explain. So this all of this happens inside of the Kubernetes releases automatically and using just work level identity. In here, since I have access to my browser, I'm running this in my desktop computer. It's running cosign to sign the images, and once it built the images with Co, the next step in the pipeline is opening the the authorization flow from Sigstore, which is asking me to provide uh, prove my identity. And to prove my identity, I can use any of these
Uh,
IDC providers.
maybe increase the browser's
Yeah,
font also a bit more. Yeah, I think this is fine.
this is the just a standard sharing of accounts that you
Hmm.
find when logging into the any site, right? So again, these are the currently supported providers. So I will use say GitHub to sign the image. I've
So
authorized it.
this ties your identity to the signature that's going to be used to sign this image now, correct?
Exactly. So I authorized it, and what the way it works is that cosign opens a socket in my computer, and the browser, probably it's too small to see, but connects to the local socket that cosign opened, and calls a webhook that passes the required identity, and the image is now signed and published. So I can, let me hide this thing here. If I can use, so this is a tag that I just signed,
Hmm.
and it's already published. The tag is version 002.
Right.
And I'm going to use cosign here to verify the newly signed image. And I'm passing the output to JQ because it's part of that. So what would people expect to see when verifying the image? Currently it's machine readable data mostly.
Right.
And this is what the verification looks like after signing the image. So
Okay.
some information that is in there is the Docker reference, which I signed, which is the actual thing that gets signed, and in this case, is the digest of the manifest. So if you remember the previous run here, we built an image for, I don't know, like 6 platforms, and what we're signing here is just the digest of the manifest. That manifest, of course, ties to all the images behind it, and so I'm stamping that one, and then some of the metadata. So I have a log index because when I sign my image, uh, all of this information gets pushed to the 6-store transparency log so that anyone can verify the signature in the future. And the other part, the important part here is that, so these are just annotations that we added. You can add any number of annotations to the attestation that you're signing. And then here's the identity. So I'm signing it with this is my email that I have registered in GitHub. And this identifies the identity provider.
Yeah.
So at this point, I have it, and I have my image signed, and
So a couple of questions here
yeah,
before we go back to the browser. Now, you mentioned that some record was created in the transparency log, so that it is easier to verify. Does that mean now? So typically, my understanding is cryptographic signing verification works where you have a public key and you have a private key. Private key is used to sign, public key is used to verify. So
oh, yeah,
is the transparency log actually storing the public key that I can use to verify, or is it storing something else?
exactly. Yeah. So when we are using here what's called in the sixth order jargon, keyless signing.
Hmm.
So the way keyless signing works is that cosign will generate, or I think it's Fulci rather, generate a key pair that it's ephemeral, and it's tied to an expiration date, and it lasts, I think, like 5 minutes or so. It uses that to sign and stores the private key in the transparency log. So if you saw
Stores the
here,
private key or public key or both?
just a public key.
Public key. Okay.
Yeah. And so if you saw here, there were no keys interchanged. They were
Right.
just generated in memory and used to sign, and then the private key is now gone. But the public key got recorded into the transparency log, and so I can come and verify without having it the image.
Got it. Okay. And the public key in this case is it actually an X509 certificate, or is it just like a general public key?
I think so. And if I remember correctly, the key is stored as well in the attestation in the image. We can
Mhm.
try to explore that later,
Sure, sure. Yeah,
uh,
yeah.
because I'm pretty sure it's there as well.
Got it. Got it. Maybe the body looks so kind of similar to the public key. Probably that is the one, or maybe
That
something
one,
else. Yeah,
yeah,
could
can
be.
actually.
We do have a question while we're looking at this from Moss. Can the image be signed by more than one person or keys? Maybe we can cover it later.
Yeah, you can. Yeah, this is one of the things that we're going to see. You can
Hmm.
you can you can attach as many signatures as you want to the image. So
Yeah,
let's inspect the body here to see what we have. Okay, so here's the body key, like you said.
yeah.
So this if you see the body here of the payload, it's base 64 encoded, and this is what I get inside. It's the record that gets stored in the. This is the actual record that gets stored in the transparency log,
Hmm.
uh, and the public key is here.
So that's the public key, and if folks are looking at the terminal like me, there is also a signature block, and it says content.
Yeah.
So is it fair to say that content is actually the signature that
Hmm.
gets verified using the public key?
Right.
Okay, got it. So we now know how signature looks like.
Exactly. So this is the going back to the previous debate. We're trying to figure out how to present this in a uh, for downstream consumers of the images
Right,
so that they can make some sense of it.
right, right, right.
So
Makes sense.
we have that one. So let me go back to my browser here. So if we see, this is the image I just,
Same request as before.
yeah,
Font.
the font, right?
Yeah,
And let me maximize this window.
a bit more, two
A
times
bit
more.
more. One more.
Yeah.
Let me take this off. There. So this is all the things that we just built and uploaded. These are all the layers, and a couple of things to note here. This is the view of my registry inside of my personal registry
Hmm.
uh, after running KO and generating the signature. So a couple of things to note here are this. I don't know if you see the blue row. Yeah. So this is the index manifest. It has the tags attached to it, and
Hmm.
then you will see this layer here, or you could say almost like an image, is the
Right.
way that is the way how cosign attaches the signatures to the image.
Right.
If you see the digest of the manifest that we signed, this one here beginning with CCAC,
Hmm.
what cosign will do is create another image, we could say, that is named with the name based on the hash that we just signed. So
Right.
it this if you see the tag of the signature, it starts with SHA-256, and then instead of having the colon, substitutes that with a dash, and then the digest and a .sig at the end.
Right.
And
We have some feedback on the font and the display. Maybe we need to increase the font a bit more again, especially the dots and colons and the dashes weren't visible earlier. Maybe one more.
one more
Yeah.
there.
Okay. So hopefully this is better for everyone watching. And just to repeat what you said, the hash in the second row is actually shows up in the tag, if you notice, in the
Exactly.
first row. And typically, if you have worked with Docker, the SHA-256 is followed by a colon, but in this case it's a dash. and I'm guessing that's how this image knows where to find its signature, because
Exactly.
it knows its own hash. So it will just look for this particular format in the registry, and if it finds it, then it knows its signature.
Right. This is the way it works. So the important thing to keep in mind is that this is a tag. So the SHA-256 is a tag. It's not the digest of that image. The digest is this one here that starts with 130
Hmm.
of for the signature, but it's tagged with a string that can be used to match the signature layer back to the digest, that is that to the index that is signed.
Right. So the first row is actually the signature stored in the registry as an OCI artifact, and the second one is actually the image that was signed. Correct?
Right.
Yeah.
And then if you see below here, you will see other layers which have that particular pattern in their names, but end up with SBOM.
Mm,
So those are, when I build my image using KO, it generated a bill of materials with all of the dependencies used to build those images. And
right.
those got uploaded as well. And these tags here, they actually point not to the index manifest, but they point to the actual images so that you can match those to that. So
Right. So
uh,
that SBOM actually has multiple images, and the hash is actually for each of those images in the SBOM. Correct?
exactly.
Yeah.
So one thing, if you think about it, we have a multi-architecture image, and that image has SBOMs for each of its child images.
Hmm.
And one thing that we could add here is add an SBOM that ties them all together. So what we
Mm,
can do, um, let's do this. Uh, let's. So I'm going to use the bomb tool that we created for the Kubernetes SBOMs to generate a bill of materials for the image that I just created. So
right.
what I'm going to pass generate subcommand, point it to the image that we just created. I'm pointing it to the tag that points to the manifest.
Right.
And let's run this. Uh, so one thing to note here is what this will do is that it will go and download. Since I push them and I don't have local copies here yet,
Hmm.
it's going to go and download all of the images and
Right.
then scan their layers to generate the SBOMs. Because if you want to have like a complete dependency information for your images, KO gave you the language dependencies of the Go project,
Hmm.
and then I need another one that gives me the dependencies of the OS layer, of the system packages and layers. And this is what we just did here. So let me let's see if this works, because maybe the font is too big, but let's try. Um, so if we let me explore a little bit this one here. So this is the SBOM information that I just generated. It lists one package, which is the tag that we of the images. So that's the first one. If you see here, that package has 8 relationships because it contains 8 things. Which, if you can, you guess what it is?
Maybe layers.
The images.
Yeah.
Because the first one is the index manifest, and
Mm,
then at the next level we can find the images. So you can see the images here. So behind the manifest, the index manifest, we have the images for each of the architectures, right? So
right.
each of them below. Then at the next,
So
yeah,
hang on. So for all of this, like tying all of this together, uh, we signed a package which composed all of multiple different images of different architecture, and uh, that is the one called supply chain demo version 002,
Yeah, that's
and that
the
package
index.
was pointing to multiple other images, which we are seeing now. So when we signed it, we signed the package but not the individual images, correct?
Yeah, when we signed at this point here.
Right.
So that's the way cosign will by default sign. You can pass, of course, each of the individual images and have those signed as well. But
Right.
by default, it will sign the manifest, which is
and
what it did there.
and in case of Kubernetes now, we also have images that are of different architectures,
Right.
but those are going to be signed individually, right?
Yeah, we're going to see once we promote this, we're going to be able to see the end. Just wanted
Got it.
to show. So if we go one level below that, we can
Hmm.
see each of the layers. And if we go to the fullest maximum depth in the SBOM that we just generated, you can see the actual packages, system packages
Nice.
inside of the layers.
Yeah.
So if you combine those two together, you get all of the information for language dependencies from Go,
Right.
and the second SBOM gives you the OS dependencies, so
Right.
you can have a clear picture.
By
So
by language dependencies, you mean all the, in case of Golang, would be
yeah,
all the Go modules.
on Go, yeah. If you want, we can fetch one of the SBOMs. Let me see if I can. Let's see if this works.
I'll try to answer one question until then. So Moz is asking, to deploy the images to Kubernetes, which tag should be used, SIG or version tag? I think I know the answer. So if you have to actually use the Kubernetes image itself, you would use the tag of the Kubernetes image, because the signature doesn't actually contain the image, right? So if you have to use the image, you pull the image tag instead of the signature tag.
Yeah,
If you have
yeah,
to
yeah.
verify, if you have to
To
verify
run,
it, yeah, if you have to verify or pull, pull the image tag, and then if you're using cosign verify, it will figure out where the signature exists
exactly.
and it will verify accordingly.
Yeah, yeah. This is more in-depth look into how cosign works,
Right.
and so we're inspecting the innards of it and the inner workings. But if you want to verify the image, you just pass the reference that you are using to run
Yeah.
the container. That same one. Um, so if you see here, what I did here is I used cosign to download one of the actual image SBOMs that code generated.
Hmm.
So when, if you remember on the browser, we had all of these SBOMs for each individual image. I pulled one of them, and this is what it's just a simple project, and these are the Go dependencies on the of the project. So what
Right.
it does, uh, me I can show you. It just shows a hello. That's
Nice.
it. That's what the project does.
Hey, look,
So
there is TGIK too. Nice.
yeah,
Okay. I think this is related to Jim's question on the chat. He's asking, any way to check the source of the contains package that is built from binary versus deb repo? So if Jim, if I may understand your question correctly, you're asking, can I figure out what what was the source of the binary that was being built, and what were the dependencies for that binary? So that would be the example just above this logo, which had the list of GoMod dependencies.
the
Let us know if we
source.
got it right or not, Jim.
Yeah. So in this case, the source information comes from, since Go is actually building my project, which so this is I'm actually right now in the Go project, and
Hmm.
Go builds this project and compiles for all of the architectures, so it has first-hand information into what we're looking at here. We are currently working to add to the bomb tool the ability to take a binary and using the new Go dependency information flags that you can pass to it, extract the dependencies. But in the end, what you want is that the SBOMs originate as close from the source of
Yeah.
information as possible.
Yeah.
So if Co is building, then you should trust the SBOM that Co produces and not try to generate it later.
Yeah. Yeah. Agree. One thing this reminded me of a discussion in security, just maybe it's a little bit tangent, but I'll try to be brief. One of the things we were discussing a couple of weeks back was in this in this application, for example, right? What's it? Maybe we can give use an example. What's the name of the application that we're looking at? Supply chain demo,
Yeah,
right?
well,
Yeah.
the name of the application that gets used in the SBOM at least is
Yeah.
the Go module name. So
Okay. Yeah.
this one here.
So in this case, let's say this is the name of our application. One of the things we were trying to figure out is if supply chain demo version 001 ends up having a CVE that gets fixed in version 002, the SBOM doesn't have that information for the version, if I'm not wrong. Or does it?
It does have it.
It does have it. Okay.
Yeah. So uh, so this is the source of the SBOM,
Right.
and each of the packages has a version. That's the document.
Mm,
So here's, for
right.
example,
And
one of the
this is only
dependencies.
possible because I am generating SBOM from the root of the repo itself. If I just had the image of supply chain demo, I wouldn't have a way to know what version of supply chain demo I was using, unless the image tag mapped with the actual version of the application. Correct.
Uh,
So I
yeah, but you can express it. You can express it inside of the SBOM. There's a way you can, at least in SPDX, you can express the version in the Git commit of the
okay.
of
So it would
the
be
of the
like a
source.
metadata to the image layer, metadata.
Exactly. Well, it's in the SBOM, and you attach that to the image, so you can check
Right.
all of that.
Right. Makes sense. Looks like Jim has come up with more context. So makes sense for the ones that have Golang dependencies with links to mods. I was thinking more about binaries that were listed in the image, like contains package lib OpenSSL. Oh, I see what you mean. Okay. And then, but I think the point is you trust the image to begin with versus picking apart the image. I see what you mean. So you're wondering if I end up having a package that is or a binary that is in the image, but it's not installed by Debian or Yum or APT, and it's also not my application binary. So in that case, what's the best way to figure it out? So I think, like you said, if you trust the image, then you assume that nothing malicious is actually part of the image, and then
Exactly.
the only thing you are adding is your own binary on top of it.
Yeah, so that's one of the reasons that you should try to have the SBOM as close as the source of information as possible,
Mm,
because right now, for example, what the bomb tool does is takes the image,
right.
opens the layer, it recognizes that it's a Debian layer,
Right.
and it opens the Debian database and scans
Hmm.
all of the packages and presents the information.
Right.
But
Right.
that could be, so this is what some people call an after the fact SBOM,
Yes.
because it's inspecting an already created artifact.
Correct. Correct.
But for example, I'm going to drop a plug here for, we are working in a very interesting project in Chainguard that it's called APCO, APKO.
Hmm.
And the idea of APCO is that you run your build, you build your image straight from the Alpine packages. So you configure the packages, run the build, and you end up with a one layer image that produces SBOMs that are straight from the source that built the image. And
Uh,
and those packages are themselves verified because they are signed by the distribution.
right.
So you don't have to do this, because if you build an image with AppCo,
Right.
it already comes with an SBOM from the time it was created.
Okay, that makes sense. And then if I have to update any of the packages that are part of the first layer, then I just rebuild the image and then it will pick up the latest.
Exactly,
Ah,
exactly.
okay, that makes
And
a lot of sense.
yeah, and we've also publishing uh, new images, like it's a little bit trying to be a successor of the Google distro-less packages, the
Hmm.
images that many projects use.
Yeah,
And we are
including
already
Kubernetes.
yeah, exactly, that
Yeah,
they are inside Kubernetes, and we are trying to build like the next generation of that.
yeah,
And we are already publishing daily images of some common bases that you can use as base images for your projects.
right.
It's still version 0.2,
Hmm.
or I think it's coming today out, AppCo 0.2, but it's already showing lots of promise and interest.
Yeah,
So it's another cool project to check out
yeah,
today.
definitely. And to finish on the Go source and version of the main package, I think in Go 1.18 there is a new feature where I am able to extract the
Right.
information if I have a binary without the source code, which
Exactly.
is again a good thing for like you said, the after the fact SBOM creation,
Hmm.
where I don't have maybe the source code and I am stuck with an image coming from a third party provider, and I want to know like what version of this binary I'm actually running, then I am able to actually now with 118 use that feature to figure out, okay, this is the version. Are there any CVEs for this version? And then
Right.
you
That,
can
that's
update.
that's exactly the feature that we're building into the bomb tool. Using
Nice.
that to extract the dependencies. This is a project that was started by uh, one of the uh, people I admire the most, who's developer guy.
Oh
So
yeah, yeah, I know him.
yeah,
Yes.
so and he's working on adding that. So yeah, it's
Yeah.
going to be. So let's jump back to this one. So
Yes.
we
One request, sorry, Purko. Can we start from the top of the terminal? So it's that way it's easier to follow along if people are looking at the video. Yeah.
yeah, cool. So we have our S1, and it will make sense to use cosign. Let me run this. So I'm going to use cosign here, and I'm going to attach the S1 file that we just created
Mm-hmm.
to the image that we published. So what you do is you call cosign attach. You can attach two images, basically any file, but the most common things that you'll see within cosign are SBOMs, signatures, and
Mm-hmm.
attestations. Attestations that can provide more certainty to where the image has been and things like that. You can add, or maybe describe the release process or
Right.
build process. So I'm going
It's
to
sort of like a stamp on your passport. Where have you been?
exactly,
Yeah.
and so that one took the image and attached it. And so let me, if I go back here to the list of layers, now I have a second layer here, which is the SBOM
Mm.
I just produced. So all of this is what happens inside of the Kubernetes staging process.
Right.
And if I were to be one of the projects under the Kubernetes organization, I would have my images staged at this point,
Mm-hmm.
and they would be ready to promote.
Right.
So,
And if you people notice in the browser, the extension of the SHA-256 dash tags basically represents what type of artifact it is. So that's why it says .sbom and .sig. Sig stands for signature.
exactly, and cosign keys on that to determine what it is. And the other one is ATT, which is an attestation.
Hmm. Yeah, that makes sense.
And okay, so that's a way cosign stores signs and keeps things in there. So let's
This is maybe a question for uh, related to AppCo from Moz. Can cosign be used to sign packages like coming from APK or packages that are .apk or .rpm?
uh, answer is uh, you can have a package and produce a signature outside in an outside file,
Mm,
but you cannot use it yet to sign the actual inner signature that RPM uses to verify it. Not yet, at least, but
yeah,
many of us are hoping to see that in a reality soon.
yeah, same here. And I think the best thing about cosign is it can sign a blob,
Right.
and the blob can be anything, including an image. So that's where the main strength of cosign has is there, in my opinion, at least.
Yeah, because you can take advantage of the whole uh, public infrastructure of Sigstore
Yeah.
to get all of the identity things in place and simply output to an external signature. All right, so let me switch here. Uh, I'm gonna switch to my work account to do some of this. So now we saw the cosign part and creation and signing SBOMs, and now we're going to switch to the actual promoter.
Hmm.
So the promoter kpromo has it also does a lot of things, but the main part we're going to be focusing is this part CIP, which is container image promotion.
Ah, okay. Yeah, I've always wondered about that.
Yeah. So the first thing to note is you can use the promoter to take a snapshot of your registry. Um, it has this. Maybe okay. I'm going to hit it and move the terminal up so that you can see. So what I'm going to do here is I'm going to run the promoter against the registry that we just used, and it's going to go and index what it finds, the images it finds, so that we can see them. And this is the metadata the promoter uses.
Right.
So uh, these are other images that I have in the same registry, and this is basically a YAML file that describes the contents of the registry. It's stored by the digest of the images and the tags associated to them. And this is I just outputted it to show how the promoter sees the registries. But the idea is that you should build your manifest using that information. So
Mm,
let me show you the way it's structured. So I think that's yeah, you can see it. So the promoter uses a series of files, uh, which are split in this particular way. It has the promoter manifest, which lists the registries, and then it has another file that's called images YAML, where the actual collection of images that we just saw is stored. If we see the contents of the uh, by the way, I'm trying to show how the promoter works because
mhm.
the promoter can actually is open source, of course, and can be used by other projects if they want. I'm not aware of anyone else using it yet, but it's certainly open source and should be able to work. One thing to note is that it can only index uh, uh, Google registries
Right.
for the
Right.
moment, but
It does end up promoting images for sub projects though, right? Not just
yeah.
Kubernetes images.
Exactly. But if you see the structure here for the demo that I'm running, uh, it's like one configuration of the promoter. If I
Right.
were to have more projects, I would add more of these directories, each with their own manifests. And but it's one big configuration that gets uh, added between all of the files, uh, and that's the way if you see the Gates infra repositories, that's the way
Right.
they are configured.
Right.
So this is the actual contents of the manifest. As you can see, we have two registries, and the first one is the source registry where we just promoted the images,
Hmm.
with the SBOMs and all of that, and it's marked with this field here as being the source. And then we
Right.
have the target registry where I will push and I will promote the images. So I'm not sure if there are any questions up to this point.
I think one thing that catches my eye at least is the service account.
Oh
How
yeah,
is that connected?
yeah. The service account is the service account that the promoter uses for authenticate itself to the registry. So if you see, the source registry doesn't have any service account because
Mm,
it's public and it can go and index the images.
right.
But in order to write to the second one, it has an identity tied to it, and it will impersonate that service account before doing the pushes.
Right. So the source registry has pull available for everyone, but the destination push is guarded with authentication. That's why we need the service account to allow ourselves to push.
Right, exactly. To write to the registry. If
Eh,
you were to have a non-public source registry,
mhm.
the theory, I mean, I haven't tried it yet, but the theory is that you could add also a service account to the source
Right.
registry, so to be able to go in and read it.
Right.
So
And then the question is, this service account is different than the one that will be used to sign the image.
exactly. Yeah, one thing to note is that currently the identity of the service account that we will be using to sign is hard coded into the register, into the promoter code, because it's not finished yet and I'm using it to test. But the idea is that we will be exposing a flag to pass a service account for that.
Right. And the idea is the configuration flag will allow sub projects to decide for themselves what service account they want to own so that they can
Exactly.
say, hey, I've signed this with my service account. So
Exactly. So
the yeah,
projects will be using by default the account um, of the Kubernetes organization when
right,
promoting. But if you were to run the promoter by yourself, or maybe we could even expose it here if you don't want to use the Kubernetes
right.
identity. But that's not a plan. That's not planned yet, and no one has, since this is not yet running. We
Yes,
haven't
yes.
heard it of anyone, but it could be potentially be done that way as well.
I see. Okay.
So I'm going to dump the information of the snapshot of my source registry to the image, to the manifest, uh, to make to seed it with the images that are stored in the source registry. So if I take a look at the file that I just created, it has the SBOMs and the images that we created, right? So now the promotion time. So the theory is that if I run the promoter and point it at the configuration, it should, and this is hoping that it works.
Yes.
I mean, it should work.
Yes.
And it will actually take the images from the source and move them to the target registry. So let's
And verify it before signing and pushing.
exactly. We should be able to see that all of that happening live. So without further ado, this is the way you do it. You pass this flag to the promoter, then manifest here, which points to the directory where all of the manifests live. And then you pass confirm to it, because if you don't pass confirm to it, it will just tell you the images that are candidate promotion candidates. But we're going to do the actual promotion now and see if it works. So let's see and if it works.
Okay. Let's see. Oh, lots of information.
Yeah. So let me go back to the beginning. So okay. So it's the first thing it does is read the registries to
Hmm.
determine. There's lots and lots of debug info. This is supposed to run in the post submits, and it's very verbose because
Right.
if something breaks, you can go in there, go and check there. So it's so every time it mentions an edge, like here, it's one of the difference between the two registries. So
Mm,
it's an image that it's going to be promoted. So it goes and checks what's in the target, what's in the source, builds up a list of what's going to be, and here it's starting to look for signatures of the things it's finding in the sources. So
mm,
it's first it's checking this digest here,
hmm.
and it doesn't have a signature, so it doesn't check anything.
Yeah.
Keeps going, keeps going.
It checked a few of them though.
Yeah. It checks actually all of the images, all of the layers that are candidates to be promoted.
Right.
All of the references are checked for signatures.
Right.
And so here it found one of the signatures was found, and it's checking against Sigstore to ensure that the signature is valid.
Right. And this is only happening like some of the images don't have signature because we haven't signed them when we pushed it to staging, right? Ideally, if we were signing everything, then it wouldn't show up like this, correct?
Yeah, remember that the way we signed currently was that we signed the manifest.
Right.
So the manifest has container images are content addressable. So
Hmm.
the manifest has the digest of the images.
Correct.
So if you sign the manifest, you sign the SHA of the manifest, then you ensure that that SHA cannot be falsified.
Right.
Then, since it addresses the actual images by their digest as well, they cannot be modified because the digest is the actual content, reflection of the content, so that the whole chain cannot be modified. If you flip one bit, all of the chain breaks, right?
Right. Right. Makes sense.
Okay, so it hit that image there and it verified it, and it keeps going. If you see
Mm,
here, it's the address we used to sign when
right.
we first built the image.
It did say something called critical. I wonder what that is about, or it just like some identifier or a field.
Hmm. Oh
Just the
yeah,
yeah, the first word.
yeah. So I think if I remember correctly, the attestation here is it divides the annotations, and there's a critical section, and I'm not sure why, but it
Hmm.
has like I assume I assume that it's the bare minimum data that you need to verify it, because it
Ah,
has the
okay, okay.
reference here
Hmm.
and it has the digest,
Yeah. Okay,
and
that
you
makes
could
sense.
say that everything else is kind of optional. So, for example, in the demo that I built with Carlos, we add these annotations of the git hash and the
Right.
tag,
Right.
and you could basically not have those, but if you add them, they get signed.
Right. Right. We have a question related to this. So now that we verified the signature of the manifest, and when we are promoting, are we going to promote only the manifest because that's the only one signed, or are we going to promote all the images?
Now it's going to promote everything. So the promoter moves all of the references that it finds on the source registry, moves
Hmm.
them to the new one. Only if it finds signatures, it will verify them, and only if those signatures are bad,
Right.
they don't get promoted.
Right. And in this case, the manifest is signed. In case of Kubernetes images themselves, would we also sign some sort of a manifest or the images?
We're going to see
We're
the
going there.
actual
Okay.
outcome of once we do that.
Okay.
So after this is here still copying and verifying. I mean, this is the verification.
Right.
Now, here it begins the actual promotion, which
Ah.
means the copying of the artifacts to the. Once we verified what could be verified, it starts copying everything.
Mm-hmm.
And so this is the copy of all of the images up to here. And
Mm-hmm.
now, here it's starting to do the signatures.
Right.
So to answer your question, we sign the actual images, not the digest.
Got it. So now, just to be clear, in the beginning you mentioned we will sign it twice. One would be release engineering signing it in staging, and one would be the Kubernetes project signing it during promotion. So when we did the first one, we signed only the manifest,
Right.
and the second time when we're doing, we're not signing the images that we are promoting with the release engineering signature, but we're signing it with only the Kubernetes project signature.
Right. This second signature that I'm adding, the first one was with my GitHub email,
Right.
which would be equivalent to the release engineering
Correct.
signature.
Correct.
And the next one is using this test account here,
Right.
which is simulating what would be the Kubernetes wide organization
Right.
identity, right? And if you see here, it's signing the actual image. We're also going to sign the digest,
Mm-hmm.
but all of since the promoter sees the images independently and doesn't work at it works closer to the blob
Yeah.
side of things instead of the actual OCI abstractions.
Mm-hmm.
So since what it sees to promote are the images, that's what we're signing,
Got
and
it.
it's
And
signing the images and also the manifest.
so now for the production registry, the only signature or .sig file I'm going to see is the signature for the Kubernetes project.
No, we are going to
Oh, we're
inspect
going there.
this.
Okay.
Yeah.
Okay. All right.
So this is the actual signing of the things. So
Mm-hmm.
signing, all of the images get signed. And we have a lot of images because we built an image for many architectures.
Mm-hmm.
Here. So let me scroll to the bottom, and it's done. So
Nice.
let's switch to the browser window, and I have in another tab here the supply chain demo where I promoted things to. So if you paid close attention to the manifest when I showed it here, I I am promoting from the source of the registry of
Mm-hmm.
GCR, and I am promoting the images to a subdirectory of the registry, not to the
Right.
top.
Mm-hmm.
The reason why is because I use this registry for other things, but
Right.
you could do it to the same one if you wanted.
Right. Right.
And this is my actual this is before we loaded the images. So if I
Correct.
refresh this, here are
Nice.
all the promoted images.
Mm.
So you can see that we have a lot of stuff here because
Mm.
we not only have all of the images, multi-arch images that
Yeah.
we built, but we also have the signatures for each of them. So if you see here, 66666.
Nice.
So what this means is in our original image, you can point before promotion, you can point cosign to verify the manifest,
Mm.
and it will tell you. But if you point cosign to one of the child images, it will not find a signature because those are not signed.
Correct.
It doesn't mean that they are less secure because the manifest is still signed, but there's no. But in the case of the image promoter, since we are working at the image level,
Mm-hmm.
we get signatures for all. I mean, at some point we could modify it to only sign the manifests, but I'm not sure if that would be we would gain much from doing that.
Yeah.
I mean,
Yeah. I think
still open
this
for
the
discussion.
current flow makes a lot of sense, because then if I'm running only an image with a specific architecture, I don't have to deal with manifest verification. I can just pull my image, verify it, and that's it.
Exactly. I mean, to be fair, you usually pull the image from using the manifest, the index manifest,
Mm.
but still.
Yeah.
So let's
W-
try
For
to.
folks who are watching, maybe give an example picking one of the container images, what the index manifest looks like.
Yeah, we can do that. So, for example, um, it was supply. So this is a. I'm not sure if yeah it can be seen right here.
Yeah.
Yeah. So that is the actual the reference that we're working on, and that tag points to the manifest, and we can use something like crane to see the manifest. So this is the actual manifest of the image. So just to do a quick inspection of it, you have the tag at the top points to this file, which itself points to the actual images below for each of the architectures. So, for example, we have here one for ARM Linux. We have Linux. So it's all of them are Linux, which is strange, but yeah. Okay, but these are all the architectures that we're using. So
Right.
I would expect to have also built for Windows and everything, but okay.
Yeah. This manifest is stored anywhere or is generated dynamically?
It's stored inside of the OCI registry.
Yeah. And this is the same one that we sign when we are in staging, or
Exactly.
that's a different one. Same one.
Yeah,
Okay.
this is the same one we used to sign, and so yeah, that's you take this file, produce the digest of it, and use that digest to sign. And that digest is also the address where it can be downloaded from. So
Yeah.
not just a tag. So let's now verify the image using cosign. Oh, first, yeah, let's verify it. So we have, this is a new address. This one here is
Right.
the new reference of the newly promoted image. The other
Right.
one was under ULabs, which is my personal thing, and now it's on my work registry under this manifest. So let's do. Okay, so this is an important part. So since we are working, and so there's a team of volunteers already working to bring uh, the Sixto project to general availability, and it's undergoing lots of infrastructure revamps. It's undergoing stress and other and penetration tests and all of that. And once everything is verified and ready to go, this experimental flag will be dropped, and you will be able to verify and do everything without passing the end variable. But currently, you have to pass it to verify when you sign things keyless. If you have your keys here, you can drop the experimental flag. But since the all of the public good infrastructure that handles the Sixto project is still undergoing its process to become generally available, it's considered under experimental, but it works really well. So let's just to wrap things up.
Yeah.
Let's
J-
verify.
one thing here is for folks who work in environments where they are not able to pull something directly from internet and still want to verify the signatures, they would be able to still do it, but then the only thing is they have to have the public keys available for them, which they can maybe download offline from T-logs, and then and then pass it on as a flag when verifying it. Or is
Yeah,
there a better way?
there are several ways to do it. You can, if you prefer it, you can run the whole Sixtor uh, platform and do a deployment locally, and
Mm,
have the full COCA and your own transparency log, everything inside of your air gapped environment if you want.
right. Well, but like for somebody who wants to verify Kubernetes images and they are signed by the full CO root and Kubernetes project, for them, if they want to do keyless verification, they won't be able to do it because I can't pull my public key. So then they would have to pass that public key as a flag before verification, correct?
Yeah, but the public key is also stored in the inside of the attestation that gets signed. Remember?
Right, correct. So they could
So
get the public key from there.
I suppose so. That would be an interesting test to do.
Yeah,
But it's
because
there. I mean, if you have the image with its signature in the registry,
hmm
you potentially have the signature there.
right, right.
So just to show the result of this, um, this is going to verify the image that we just signed. So this is what it looks like what it looks like now. So if you see, this is the actual verification that is now going on the um, on the image.
Mm.
This first part here is the first signature that we added to the origin in the original registry, right?
Yeah,
And then this is the original signature,
correct.
and then right here is a break between the two,
Ah, okay.
and this is the second signature, and now the reference points to the new one. An
Mm.
important thing to note is that both of those attestations are valid for, and they don't. The actual Docker reference does not matter because since we are signing the digest of the image, they are valid, and the either of those attestations and can be used to verify images in the source repository or in the target repository.
Correct. Yeah, that makes sense.
And here's the issuer. So the original image was signed by my GitHub account,
hmm
while the second one was with uh, a Google service account,
Right.
and the identity is right here.
Yeah, that makes a lot of sense.
And just to not leave things out in the air, I added this annotation here, which lists the target registries that get where the image gets promoted to, just to have them somewhere. I mean, it's a non-standard annotation, just to have that information recorded.
Right. So this is
And
the URL for the destination registry.
exactly.
Yeah,
And yeah, that's how it works,
great.
basically.
I definitely learned a lot today, and we were able to get everything working pretty much end to end, although they weren't really Kubernetes images, but this is how pretty much
Exactly.
it's gonna look like.
Right. Was just a test image, but it's exactly the same process and the same tools,
Right.
which are going to
Um,
be
I think uh, we almost close to a couple of hours since we began. Maybe as we wrap up, I wanted to explore things from an end user perspective. Like, okay, you've Kubernetes community signed images. I'm very happy, and as an end user, I want to now use it and make sure I can verify it whenever I spin up a static pod of my Kubernetes components. So there are some aspects that I've some things I've heard, like an you can use an admission controller like co-signed with
Mhm.
the ED, that will allow you to verify signature at deploy time. But one of the things I was wondering is that wouldn't work for API server, because for API server to come up, you need that for admission controller to be used, you
Uh,
need API server, and
exactly.
for you can't verify API server and with an admission control because it doesn't exist. So you could use it for things like proxy or conformance images, I'm guessing. But things like API server, controller manager, scheduler, if I have to verify it, how would an end user do it? Maybe there is not a good answer, and that's fine. But I was just curious.
Yeah. Well, there are two things to note there. So the first is that the admission controller uh, can. I'm not sure if yeah. I'm not sure if it can be used. We'll have to definitely for the API server it cannot be used.
hmm
I'm not sure if for the nodes, probably not, but I'm not sure. But the one of the things that have been one of the issues that has been raised in the past is that this the verification of the image signatures should also be happening at the runtime level, so at
Correct.
the container runtime level.
Yeah.
I think the first person to note this to me was Sasha Gruner,
Hmm.
and I think he actively is a contributor to the Cryo project.
Yeah.
So at some point, it would be nice to see six-door integration at that level. Uh, but yeah, the cosigned admission controller is meant to check your applications more than the
Hmm.
actual Kubernetes images.
Yeah. Yeah. That makes
One thing
sense.
I've been thinking is that maybe we should add the verification to tools like, um, for example, we at the KOps level or other cluster provisioning tools, so that
Hmm.
when they download the images, they can check them.
Yeah. Yeah.
Um,
Even KubeADM maybe.
QADM, yeah,
Yeah. Yeah. That makes sense. And I almost also think it could be a spec update in CRI implementations, where you say as a standard for container runtime, we are going to now want every container runtime to support verification, and this is how the interface would look like. And then containerd cryo, everyone can come up and implement that on their side, so that any runtime will have the exact same way of implementing it, however you want, and then that allows us to really in real time verify even things like API server, HCD, scheduler manager without a cluster being present.
exactly. And so one of the obstacles for that is that if you think about the way that Cosign attaches the signature,
Hmm.
it's a it's a very clever way of doing it, but it's not codified into the OCI standard.
Right.
So OCI is working on. There's still a debate going on how to do the official way of attaching things to your images.
Right.
And once that happens, Sixor will move to adopt that standard, and then uh, we can start thinking about modifying other
Yeah.
downstream specifications.
Yeah. That will really be like really real end to end image signature and verification once that's
Right.
done. I really look forward to that day. And thanks so much for sharing your knowledge, Turko. We learned a lot, and also your expertise and your bravery in doing a live demo in front of so many people. And we have a recording now that it worked and it will work. So I'm very happy and look forward to version 124, where we'll have the first set of signed images.
Yeah, me too. So keep an eye for some of the pre-releases. Hopefully, we can sign the next ones.
Hmm.
Uh, Fingers crossed to see tools getting into the right place. And yeah, and if I would like to invite anybody to who's interested in this kind of subject matters to join our release engineering meetings every Tuesday. We're happy to see you there and come, ask any questions, collaborate, contribute if you want to. Happy
Yeah.
to have you there.
And for folks for whom maybe the time doesn't work or their employer doesn't allow them to use Zoom, they could join and say hi on Slack, and that should be fine as well, right?
Right on the Kubernetes Slack on SIG release and the release management channels. Happy
Nice.
to answer any
Yes.
questions there.
I can personally attest. People in on those channels are really great and kind and welcoming. So, if you are unsure and kind of scared about how it will go, don't be scared. Just go and say, "Hey, I want to work on it," and we'll feel. I'm sure you'll find something interesting to do.
Exactly. We're always looking for more help.
Yeah, exactly. Okay, so I think it's time to wrap up. Thanks everyone who hung along with us for almost 2 hours. Hope you learned a lot. And for folks who are watching the recording, hope you enjoyed what we discussed today. Feel free to share your feedback on Twitter or any other way that you can find us. And then we'll be more than happy to review it, learn from you, and do a better TGIK every single episode. So thanks a lot, Turko. Hope everyone has a good weekend, and hope to see more signed images in future.
I'm sure we will. Thank you for having me, PJ.
No worries. All right. Bye, everyone.